Hello everybody. In this video we are going to do a quick discussion about what are type 1 and type 2 errors. Let's go do a little drawing real quick and let's talk a little bit about what type 1 and type 2 errors are. Let's see if I can get my pen working here in just a second. There we go. Let's erase it out. Okay, there we go. Okay, so let's draw up a little table for ourselves for our type 1 and type 2 errors. So on the left-hand side, we're going to say this is what the data suggests. Okay, so when we collect our data and we run a hypothesis test, our data could suggest to us to reject the null hypothesis. Or it says that our sample is really far away from the hypothesized mean, so we think that the true mean is different, less than, greater than, whatever the baseline value was. Or we could say that our data suggests that we don't find any difference, or we fail to reject the null hypothesis. Now it's always true that we could have just gotten a weird sample. We could have just gotten a weird sample and it threw our results. What we don't ever really know is what we call like the truth. It's possible that the null hypothesis is true, and it's also possible that the null hypothesis is false. So if we reject the null hypothesis when the null hypothesis is true, we have made here what's called a type 1 error, which is a false positive. Or we're saying that we have found significant results when really there's not, and this is indicated to us by alpha. It's an error that we make when we reject the null hypothesis. Unfortunately, we never know if we've made a type 1 error or not. It's something that we simply are not aware of. But we can protect ourselves against it by doing a couple things. Increasing the sample size is a great way to help protect yourself from making a type 1 error. And also, if you are really concerned about it, you can lower your alpha rate. Okay, another thing that we can do, let's put it over here for our other error. If we fail to reject the null hypothesis when the null hypothesis is false, that's what's called a type 2 error. And this is a false negative. This is us saying that our data didn't really show that the null hypothesis is wrong, but in reality, the null hypothesis is wrong and our data just failed to see that. And this is signified by a symbol of beta. We don't really go deep into this, so I'm actually going to just erase that and we're going to leave it like this. Now these other two options here are actually good options. We put smiley faces there. If we reject the null hypothesis and the null hypothesis is false, that's our data helping us reflect reality. Same thing if we fail to reject the null hypothesis and the null hypothesis is actually true, that is us reflecting reality. Okay, so now that we kind of have this little table going on, let's look at a scenario and see if we can't understand if we can apply these principles to an actual problem. So here it says you want to conduct a hypothesis test to see if the average speed of your cable internet connection is more than 180 or 160 megabits per second. So for our parameter, we say that the true mean is what we are testing greater than 160. Notice how the null hypothesis and the alternative hypothesis are both mu's and they both have 160s. We are testing that it's greater than because we want to see if the connection is more than 160. The null hypothesis, in this scenario, it gives you both an option that you could put the equal sign or the less than or equals. I prefer doing the equal sign, that's my preference, but a lot of times you will see this as less than or equal, that there's a school of thought that the null hypothesis should be exactly opposite of what the alternative hypothesis is. So if the alternative hypothesis is greater than, we need to have a less than or equal than symbol here. Okay, so in this scenario, a type 1 error would us be saying that we have a very fast connection when in reality it's just 160. So if you look at these options, these are different ways that we can kind of put it together. Let's see what the right answer is. So it says you decide that the mean speed of your internet connection is more than 160 megabits per second, when in reality, the speed of your internet connection is not more than 160 megabits per second. So that's making a type 1 error. It's a false positive. You think you've made some big conclusion, but in reality, the true mean really does reflect the null hypothesis. Okay, so let's go down here. So a type 2 error. So let's look at these for a second. Look at those. Pause it for a second if you want. And let's go over these. So type 2 errors, we are failing to reject the null hypothesis. It's a false negative. We don't think that our internet connection is very good, but in reality it is. So let's look at this. It says, you decide that the mean speed of your internet connection is not more than 160 megabits per second, when in reality the speed of your internet connection is more than 160 megabits per second. So that's how you kind of go through and you look at type 1 and type 2 errors. We never know if we actually have made a type 1 or a type 2 error, but we know what we're at risk of. If we reject the null hypothesis, we are at risk of making a type 1 error. If we fail to reject the null hypothesis, we are at risk of making a type 2 error. In all cases, like if we want to help protect ourselves, increasing the sample size is a great idea. And then if you want to start to lower down your type 1 error rate, you are going to reduce your alpha level. Type 2 error is a little bit more tricky to deal with, and we will discuss that maybe later. All right, have a good one, y'all.